Okay, in previous classes we learned about differentiation and integration, the concept of both, and for practical uses you have to remember a chart which you can get from any standard book of calculus and from your school books also, that there is a chart of ddx of x is suppose 1, or integration of x dx is x square by 2 plus c. These results you can get from your book. And I can see one thing is, suppose ddx of x is 1, then what will be integration of 1 into dx? That will be x plus c. That means we told you that integration is just anti-differentiation. So if you differentiate a function and you get the result, if you integrate that result, you will again get that function. Okay, and in the same way, integration x dx is x square by 2 plus c. If you differentiate x square by 2, then you will get 1 by 2 into ddx of x square is 2x, so that is x. So differentiation and integration is just opposite process. Okay, so you have to remember a lot of things. You can't always derive things from definition. Like if I give you ddx of log x, then if you try to do it from the definition, it will be tough for you, because then you have to know about Fourier series, how to expand the log function. So otherwise you can find log x plus delta x, what will be that? So, and when you will put limit delta x tends to 0, then for approximations also you have to know how to approximate a function. So for these reasons, for practical purposes, better is you have to remember the charts, and it's easy. Millions of students do remember these formulas. Okay, so today we'll learn some basic concepts like displacement. What is displacement? Suppose you are here at point A and you move like this and you reach to the point B. So you traveled in this way, you traveled in this path. So the distance you covered is the measurement of along this path, but your displacement is your initial position and your final position, and the straight line distance of between these 2 points. So for displacement, it doesn't matter along which path you moved. It's only depend on your initial position and your final position. Suppose you are here at position A and you move a long path and ultimately reach to the same point A, then your displacement is 0, because your initial point and final point are same. So this is the concept of displacement. And of course displacement is a vector, because this your initial position and final position, and that's distance. It has a magnitude. This distance has a measurement, so it has a magnitude and a direction also. So that's why displacement is a vector. What is scalar? Scalar means it has only magnitude, and vector means it has magnitude as well as direction. But that is not the complete definition, because you have seen in your household that current wire. Suppose this is a wire and current is passing through it, so it is also has a magnitude. Some amount of current is flowing, so it has magnitude, it has direction also. But is it a vector? Is current a vector? Because it has both, it has magnitude and direction. but it is not a vector. Why not? Because you can move this wire in in any way, right? It will always flow along the wire. You can move this wire according to your will. Okay, so it has not, this direction is not unique, that's why it is not a vector. And so what is the complete conditions to be a vector? That is, it has to be it must have magnitude as well as direction, and it has to follow vector addition rules. This current does not follow vector additions rules, so this is not a vector. What is vector additions rules? There are two rules. One is parallelogram law and one is triangle law, and we will learn it later. Now come to another concept, that is speed. What is speed? Speed means your covered distance, how much distance you have traveled, that is important. So if I say how much distance you covered, then you have to measure this path, the distance of this path. But if I say what is your displacement, then you have to measure the straight line distance from your initial point to final point. Now if I find speed, what was your speed, then you have to find the covered distance, the whole distance you covered, by the total time you have taken, that is your speed. And what is velocity? This is just, speed is a scalar. Why it is scalar? Because it has not unique direction, the direction is changing at every point, so it is not a vector. Velocity, so it is just the measurement of the distance, it has just magnitude, so it is scalar, and time is also scalar, so speed is a scalar quantity. And velocity is displacement by time, so that is the difference between speed and velocity. Displacement by time, so the displacement by the total time you have taken to reach from A to B, so that is your velocity. And so this speed and velocity we found to go from A to B, that is actually average speed and average velocity. Okay, because we have taken total distance or displacement by divided by total time. But if I try to find speed at a particular point, because this is not necessary that the whole path is covered and in every point the speed was same, that may not be the case, because here the speed may be higher, here the speed may be lower. When someone is traveling from a point to another point, it does not necessary that in every point he has the same speed, it may not be the same. Okay, so when we find total distance by total time, then we found average speed. But when we want to find instantaneous speed at a particular point, then what we will do? Instantaneous speed. Instantaneous speed means limit delta t tends to 0, delta s by delta t. Here delta s, or say delta l, here delta l is denoting that at that point in which you are trying to find instantaneous speed, suppose in delta t time you are going to from this point to this point, so that is your delta l, the distance of between these 2 points. and the time you are taking to reach from this point to this point, that is delta t. So if you divided delta L by delta t, then you will get speed at that point, and limit delta t tends to 0, because when these 2 points will be closer and closer, you will get instantaneous speed more accurately. And instantaneous velocity is the same thing, just in case of distance you have to take displacement. And velocity is a vector quantity because displacement is a vector. Now there is another concept, that is acceleration. Acceleration is velocity by time, because velocity also can be increased with time or decrease. So the change of velocity, so it will be delta v, if I denote velocity as v, delta v by delta t. So that is our acceleration.